Welcome to the party demonstration of 7-level inverter by using microcontroller. So here we are going to provide the 7-level signal inputs to the 3 H-bridge circuits. So here we are using this is a 3-level inverter and the next 5-level and 7-level. So here we are connecting these circuits in such a manner like this is the main circuit we are following. So for this one, this will generate the 3 levels and 5 levels, and after this we will get the 7 levels. Like that, when we are using the multiple of this H bridge, then the odd number of the level which will be generated. So if we use the 4 H bridges, then we can get the 9 level, like that 11 levels. So in that manner we are going to multiply that, and the output is we'll getting in this sine wave format. So this sine wave we are getting from the final stage. So that is the main input to this step up transformer, so which will step up the 12 volts AC to 230 volts AC. So that is the input to this load here we are using. So we have interfaced these H-bridge circuits. So directly at this H-bridge circuit interface at the A0, A1 and B6, B7 and C0, C1 pin of our microcontroller. Parallelly we are generating the 50 hertz of clock frequency alternating to the 3 and then 5 and then 7. I mean, whenever this 3-level inverter H-bridge circuit getting switched on, so we will get the on waveform for the duration of 20 milliseconds. So like this one, 10 milliseconds, because we are using 50 hertz of clock frequency for the inverter circuits. So 1 by 50 equal to per pulse, it will take the 20 millisecond. Then off waveform and positive waveform and negative waveform will take 10 and 10 milliseconds. So initially there is a 3-level. Only the 10 milliseconds off time will be continuously on. Then after, in that 1 by 3rd, nothing but 6 milliseconds. Again here 3 milliseconds. So like that we are dividing that, so that parallelly we will get the output of 7 levels directly. So means 3 level we are getting on for 10 milliseconds of duration. So parallelly final output, the resultant output will be getting this one in 7-level inverters. So we can see that. So it's 0, this means 1, 2, 3, 4, 5, 6, 7 levels. You are getting that. So this is the first level, second level, third level, 4, 5, 6 and 7 level. So like that, same for the negative current also. So it will be the negative current generation will be achieved with help of only H-bridge circuits. So because the H-bridge circuit can change the polarity by switching the alternating MOSFETs. So consider this 1, 2, 3, 4 MOSFETs. When we switch on the 2 and 3 MOSFETs, then we'll get the positive waveform, and next 1 and 4 MOSFETs will get the negative current. So for that purpose only we are making use of H-bridge circuits. For that we are using IRF 540 MOSFETs and 4 MOSFETs per H-bridge. So here we are providing the 24 volts DC inputs. So then we will get the directly 24 to 230 volts. So here the 20 volts DC is a rechargeable battery we are using. So here we can see that 6 volt 1 amp batteries of 6 numbers are connected in series. 4 volt 1 amp. So each battery of 4 volt 1 amp and 6 batteries are connected in series. So we will get 24 volts 1 amp is a DC output, and which is a rechargeable battery. So initially if you want to charge a battery, then on the 230 volts power supply to this transformer, so this light will show the status of the battery charging. It will take 6 hours minimum, 8 hours maximum to be fully charged. Once the time completes, automatically these diodes will block the current flow from the transformer to the battery, and after that you can switch off the power supply after time completion. And let us see the demonstration on the power supply to the motherboard. So here we are using the PIC 16F72 microcontroller, which will generate the 50 hertz of clock frequency for each H-bridge alternatively. So before on the kit, check this battery in off state only. So first on the motherboard and then on the battery, and after utilization don't forget to off that, because if is there any short circuit occurred, the MOSFETs will may get damaged. In order to protect that, we should off this first and then off the microcontroller. So we'll show you how the microcontroller generates the signal. So till this light on and off 2 times, there is no signal to our H-bridge circuits. You can see that. So when I switch off the microcontroller, there is no signals to the MOSFET circuits. So output is 0. This is a reset the microcontroller, means it will only restart the controller, it won't erase the code which we have already loaded into the microcontroller. So before on the whole kits, off the power supply to that and off the power supply.